Dijkstra's algorithm. The purpose of Dijkstra's algorithm is to compute the weight of the shortest path from the starting vertex to all other vertices. Now, how does it do that? Well, suppose vertex A is my starting vertex. The first step would be to assign 0 to that vertex. And the reason for that is because we already know what the weight of the shortest path from A to itself is. It's 0. Because the shortest path from any vertex to itself is simply to stay put. That all being said, we don't know what the other values are for the other vertices, so all the other vertices get assigned infinity. We give it the largest value possible, then as we progress in the algorithm, we'll reduce these values as we go. So, like we said, we already know what the value is for vertex A, so we're going to go ahead and finalize that vertex. And in Dijkstra's algorithm, anytime you finalize a vertex, the next step is to relax each edge coming out of that vertex. What do I mean by relax? To relax any edge connecting vertex 1 to vertex 2 means to compare the value at vertex 2 to the value at vertex 1 plus the weight of the edge connecting them. Written in pseudocode terms, if the value at vertex 2 is greater than the value at vertex 1 plus the weight of the edge connecting them, then that means we have found a shorter path to vertex 2. Thus, we're going to set vertex 2 equal to vertex 1 plus the weight of the edge connecting them. Now, let me demonstrate what I mean. We're starting at vertex A, and I'm going to relax the edge that goes towards B. In this case, A is vertex 1 and B is vertex 2. The vertex that you just finalized is always vertex 1 in this situation. So we're comparing infinity to 0 plus 4. Clearly, infinity is a larger value than 0 plus 4. Thus, vertex B's new value becomes 0 plus 4, or just 4. Next, we're going to relax the edge going from A to C. Here, we're comparing infinity to 0 plus 8. Clearly, infinity is a larger value, so C's new value becomes 8. Now that we've relaxed all of the edges coming out of A, the next step is to finalize the vertex with the smallest value amongst those that have not already been finalized. A has already been finalized, so we're not considering that. So amongst the vertices that have not been finalized yet, the vertex with the smallest value is B, so we're going to finalize it. Now, why do I feel comfortable finalizing B right now, even though we're clearly not finished? Well, take a look at the graph. Any other path to B would clearly have to go through C. And we already know the weight of the edge connecting A and C. It's 8. Also, when we use Dijkstra's algorithm, we assume that there are no negative edges. If your graph contains negative edges, then do not use Dijkstra's algorithm. The algorithm will not work. So, because we're assuming negative edges do not exist in this graph, and every other path to B would have to go through C, which means that path is guaranteed to have a total weight of at least 8, we can feel comfortable assuming that B's current value is as small as it's going to get. Thus, we can finalize it. So now that we've finalized B, the next step is to relax each of the edges coming out of B that have not already been relaxed, beginning with the edge connecting B and D. In this case, we're comparing infinity to 4 plus 8, and clearly infinity is larger, so D's value gets updated. Next, the edge connecting B to C. Here we're comparing 8 to 4 plus 11. In this case, 8 is not larger than 4 plus 11, thus meaning we did not find a shorter path here, so C's value remains unchanged. Now that we've relaxed each of the edges coming out of B, next step is to finalize the vertex with the smallest value that has not been finalized yet. That vertex is vertex C. And now we're going to relax its out edges. For the edge connecting C and G, we compare infinity to 8 plus 7. Clearly, infinity is larger, so G's value updates to 15. Next, C to H. Here we compare infinity to 8 plus 1. Clearly, infinity is larger, so H's value updates to 9. So, we have relaxed each of the edges coming out of C. Next step is to finalize the vertex with the smallest value that has not been finalized yet. That is vertex H. And now we're going to relax each of H's out edges that have not already been relaxed, starting with the edge connecting H and G. Here we compare 15 To 9 plus 5, 15 is a larger value, thus meaning we have found a shorter path to G, so we're going to update it to 9 plus 5, which is 14. Next, the edge connecting H and F. Here we're comparing infinity to 9 plus 2. Clearly infinity is a larger value, so F's value updates. It becomes 11. All of H's edges are now relaxed. Now we're going to finalize the vertex with the smallest value, that is vertex F. And now we're going to relax each of its out edges, beginning with the edge connecting F and D. Here we're comparing 12 to 11 plus 4. 12 is not a larger value, thus D's value goes unchanged. Next to the edge connecting F and E. Here we compare infinity to 11 plus 14. Clearly infinity is larger, so E's value updates. Next, the edge connecting F and I. Here we compare infinity to 11 plus 10. Clearly infinity is larger, so I's value updates. Now all of F's edges have been relaxed, so we're now going to finalize the vertex with the smallest value, that is vertex D, and now we're going to relax each of D's edges. First, the edge connecting D and G. Here we're comparing 14 to 12 plus 2. These values are the same. 14 is not larger, thus there's no reason to do anything. G remains the same. Next, we have the edge connecting D and E. We're comparing 25 to 12 plus 7. 25 is larger than 12 plus 7, so E's value changes. It changes to 19. All of D's edges are relaxed. Now we're going to finalize the vertex with the smallest value, and that is vertex G. That being said, all of the edges coming out of G have already been relaxed, so we're going to skip that step and go ahead and finalize another vertex. And the next smallest vertex is vertex E. And then we're going to relax the single edge coming out of E that has not been relaxed yet. Here we're comparing 21 to 19 plus 9. 21 is not larger, so I's value will not change. All of E's edges are now relaxed. Thus, the next step is to finalize the next smallest vertex. I is the only one remaining. All vertexes have been finalized, thus the algorithm is complete.